This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back. This is Uptime episode 21, and on today's show, we've got a bunch of great topics for you. First off, we're going to talk a little bit about financing for offshore wind. So there's a new type of loan that's become common with onshore wind farms, but it looks like it might become viable soon for offshore, so it's exciting. We'll talk a little bit about hydrogen. Germany's got some things in the works. GE is also using supercomputers to figure out airflow, some of these complex just types of circulation out there in the ocean. Pretty interesting. So they can kind of predict what some of these offshore sites, what they might yield. And then we're also going to talk a little bit about crawling robots, flying drones, some new technology in wind blade damage detection. And lastly, there's a pretty interesting paper on leading edge erosion that we're going to cover. A lot of really interesting takeaways from that.
A lot of exciting things in wind news this week. I really want to talk about that GE supercomputer because I think that's a cool technology. But let's start off with the offshore wind and the financing. You want to describe that a little bit deeper?
Yeah, so non-recourse loans could really lower wind energy's fixed costs. And it sounds like this is basically I guess unsecured isn't exactly the right word, but unleveraged loan. Is that how you interpret this?
Right. It would be like getting a mortgage on your house, but they can't come take the house if you don't make the payments.
Yeah, so it sounds like it's basically secured by the future profits. So
right.
Pretty interesting that I guess lenders are starting to feel like the offshore floating technology is, to the point where it's, I guess, maturing, where they feel comfortable that, hey, this is not going to just topple over and our investment will be gone, because if we can't take the physical assets, then we have nothing. Like, they need this to keep running to get paid. But that sounds interesting that if the market's getting there, that these non-recourse loans will potentially pave the way for a lot of offshore floating wind farms.
It will, if they're getting confidence in the ability of those offshore sites to produce energy even late in the lifetime, which is what it's all about, then the risk goes way, way down. So it'd be like investing in a slot machine, right? The slot machine is going to put out, no matter what you do. As long as the slot machine doesn't break, it'll always be producing revenue for you.
Yeah.
It sort of works like that. Like, you don't actually own the slot machine. You own a percentage of the outcome of the slot machine, but you help finance the slot machine. Not a bad investment as long as the slot machine doesn't break. And in this case, as we'll talk about later today, the offshore wind turbine performance is not necessarily guaranteed. So this is going to be in conflict, right? Having a non-recourse financial situation is going to be based upon the wind turbines continue to produce at some reasonable level at years 15, 16, 17, 18, 19, 20 plus. How do you get there? And are the designs we have coming out of the factories today going to be able to do that? So there's bunch of dispute about that right now. It's some really interesting papers coming out in the last month or two discussing those outcomes. So
yeah, and of course, this
deeper.
And this is an article from Green Tech Media, good reporting from Jason Dane. But they said like this isn't brand new technology, the floating wind turbines. Like, they're stealing from oil and gas. Like, they're not reinventing the wheel. Right. They're saying, hey, we've been doing this for a long time offshore. How can we apply this to wind? So it's quickly maturing. Which again makes sense. They've been doing stuff like this way out there in the open ocean for a long time. So it sounds like they're getting close.
What's your worst case on an offshore wind turbine? It sinks, right? Falls over.
Yeah.
That's your worst case in that situation. That hasn't
dolphin
happened.
Attack. They're like, get this out of our ocean. This doesn't belong here. Yeah.
Flipper goes crazy. Yeah.
Exactly. But no, it's interesting to forecast for like what the worst possible waves would be like with a crazy storm. Because I mean, you've seen some of the like the deep sea fishing. I mean, those are intense. To think that a wind turbine could float in conditions like that seems crazy. But then again, you see these oil and gas rigs out there, and
They're out there.
they don't go under. So just
Right.
a testament to the engineering. It's pretty incredible.
It is. And even the tsunami situation, which I think is in my head has always been the worst case when you got a wave, it sucks all the water out and it pushes all the water back at you. Designing against things like that is crazy. I'm not sure the floating wind turbine is going to be able to handle that kind of situation. So that's one of the things about off coast of Japan, because that's where a lot of tsunami activity happens. But in everybody's mind, to get to a financial situation that's stable, essentially that turbine installation cannot go away. In any possible circumstances, just the downside risk would be huge there. So it seems like we're getting to the point, though, in evolving engineering-wise to a stable situation, which is good, which is where we should be at this point.
Yeah. So some news out of Germany. This article is via renews.biz. Germany's backing the Ørsted green hydrogen team. So they're trying to, obviously, along with everyone, to slowly decarbonize over time. I guess maybe slowly is not the word, but just trying to get there, I guess, as soon as we can, which is still 5, 10, 15 years away, right? But
Yes.
they're really going hard after hydrogen. And, this project sounds like it's pretty involved as far as, just like the funding that they require. There's just a lot of investment. It just seems like there's a lot going on, but they're going to produce green hydrogen, transport it, have their own gas network, and it'll be used in industrial processes and a lot of different things. So what does this mean here?
Well, I want to know what green hydrogen even means. If there's green hydrogen, are there other colors of hydrogen? I don't
Right.
understand that terminology, because it just seems like hydrogen, only one possible solution for hydrogen is going to be discussed. And I don't know if that's the right answer either. Obviously, things evolve over time. And if I know we can remove hydrogen from essentially fossil fuels today, and it's a much more efficient method to do it. If that gets us to the situation where we can get to electrolysis, or essentially, taking water and breaking it apart into hydrogen and oxygen, that process will take us longer to get to. So what do you want to do? You want to continue to burn diesel fuel until you get to green hydrogen, or do you want to get to hydrogen? Because I think the answer is to get to hydrogen first and then worry about the green secondarily. But that's not sometimes where the European consortiums go. They go for the big thing, and then it may become just like Germany has gone through recently, where they have devolved back into a lot of coal and shut down some nuclear sites. I'm not sure that made any sense either. So if they're going to get to a hydrogen, great. If they want to do hydrogen sooner, awesome. But there needs to be some interim steps and the willingness to take those interim steps to get to a bigger hydrogen future. Don't you think, Dan? I mean, it just makes logical sense.
Yeah, I mean, it says here that in phase one, which would run about 5 years, that a newly formed joint venture is going to build a 30 megawatt electrolyzer to produce green hydrogen. So I guess that's what they mean. They're doing electrolysis. And then the second stage is scaling that up to 700 megawatts. So, which is, they say, the electricity generated by a typical offshore wind farm. So,
right.
Yeah. So it looks like they're just kind of going all in on the electrolysis process. Yeah.
Right. Which is just a very inefficient process, which everybody knows, right? We know how to do that. We've done that for hundreds of years at this point, being able to, figure out how to separate hydrogen from water. But if it's not the most efficient way to do it, man, it's like I said here, the infrastructure to do that's going to be complicated, and it may not be the short-term solution.
Gotcha. Well, and then our last segment here on some news is that GE wants to give offshore wind a boost through supercomputing. So interesting PDF by Justine Kalma. And Alan, what are your takeaways from this? Because it sounds like their goal is to really understand some of these interesting wind patterns offshore, like you said. Like you don't exactly know which. It's just not just, hey, wind out here is blowing 30 miles per hour in this direction. It's just not that simple. So,
Right.
what did you interpret this supercomputer solution?
Well, as an engineer, it's like, here are the keys to the candy store. Have fun. And anytime you get access to a supercomputer, you're like, wow, okay, let's see how fast it can go. Let's see how big of a problem I can throw at it, and let's see if it'll really do what and a lot of the larger wind turbine companies are really wanting to do, is to look at a wind turbine site as a system, not as individual wind turbines, but to look at them next to one another, relative to one another, and how the airflow of one wind turbine affects the next one down the line, and how you can minimize turbulence there and increase overall output of the entire farm. The only way to do that, well, there's a couple ways to do it. Empirically, you can just go out and just try a couple things on a wind turbine farm and say, well, we're just going to guess at it and take some empirical data and try to put some plots on a chart on your Excel spreadsheet and try to figure that out. The better way to do it is to look at it computationally if you can, and the supercomputer is the only way to do that, because aerodynamic problems are very, very, very complicated and they eat up a lot of CPU time. So GE having access to that, and it sounds like, was it Oak Ridge National Laboratory was going to basically open the doors for them to go do that. I think Oak Ridge National Laboratory has been historically a nuclear research laboratory. So my guess is that they've been using supercomputers to determine nuclear detonations, probably. So those supercomputers tend to be very, very large and powerful to do nuclear detonations. So this application would be great. I'm really wondering, we've talked about this a couple of times recently, where some of this technology and some of this information just kind of gets sucked into a vacuum and you never hear of it again.
Yeah.
And I hope this doesn't happen, right? Because we're trying to make the whole industry much more efficient and powerful. And if we don't put some papers out discussing how this can be done or what the benefits are, then we're losing. And the industry is going to lose, and that's not good.
Yeah. So it sounds like they're going to study especially these coastal low-level jets, which are air currents that really don't follow typical wind patterns. And they said they can just like rise rapidly up and then just suddenly drop off. And so they're really hoping to understand how that's going to affect an offshore wind farm, so they can obviously plan, to get as much efficiency as they can.
Right. And we live on the East Coast. I'm not sure exactly what they're talking about in terms of these jets. I mean, I've been to the shore a number of times.
Yeah.
And it's just windy near the shore. And I don't know if it's a specific location. Is it kind of down towards North Carolina, where there's stronger winds, or up our way, which towards Massachusetts and New York, or when the winds are maybe stronger coming off the coastline? And that's something I hadn't heard of before, but it sounds like it's a real local effect closer to the ground, not actually up where most wind turbines operate. But if it creates additional energy, perfect. Use it.
All right, so let's jump to a little bit of engineering talk. So first here, an article from machinedesign.com talking about crawling robots, flying drones, and obviously we talked with the CEO of SkySpecs, Danny Ellis, in the past about drone technology and autonomous wind farms. And this is something that he mentioned, the crawling robots and being essentially able to automate this whole process of getting to potentially even repairs with one of these things. So pretty interesting technology to, attach something like this, have it just creep around, get really good resolution photos. It's got LiDAR capacity. But I mean, do you think this is going to be viable anytime soon, or is this kind of one of those pie in the sky things?
Oh, it's viable, and what they're trying to do is put systems on these robots that can detect structural issues that are sort of deeper into the blade structure. That's hard to do.
Yeah.
So you're going to need something that's stationary, it's physically mounted to the blade typically to do that. But they're completely in competition with drones, and if drones can figure out a way to get the same amount of information, it'll be a drone world quickly. Just because I think it has to do with speed. right? The Sky Specs can do, what, 15, 20 turbines in a day?
Yeah.
It's some crazy number. And it's so fast and so automated, and it's taking so much data that the efficiency there can't be ignored. The crawling robots seem to be more in tunes of we needed to replace coatings maybe, or look at very specific things that involve more investigation. That technology is sort of secondary. So I think your first line of defense in most of these situations are airborne drones. That's the first one. Just get a look at it, see what's going on. And if I need a subsequent drone to come in or a robot to come in and do a repair or take some x-rays or whatever else they want to do, that crawling technology does make sense, but it's not going to be the primary investigation method. I don't think. Not yet.
Yeah, I just wonder how, I mean, they've got to attach the blade. They've got to, it just seems like a much slower, more cumbersome process to have a robot attaching than flying. That just seems, but again, some of those technologies might not really see through the blade as well if they're not physically attached to it, perhaps. Just like an ultrasonic, you've got to touch that to your skin to, see your newborn, your unborn baby, stuff like that, to see what's inside. It's not like they can just hold that, 2 feet away from you and see inside. So I guess there's going to be give and take, but you wonder if these drones can just like land on the blade and then just do the same thing. You need a hybrid thing, or just it gets close like a murder hornet. Murder hornet's gonna fly in, but then he's gonna land on you and then sting you. He's not just gonna sting you from a couple feet away. So taken from the animal kingdom.
Exactly, we're taking animal technology, but I was reading an article just this week, which is talking about being able to sort of sticky surfaces, like a gecko's feet is kind of sticky. Mm-hmm. And it started cranking the gears in my head, like, oh yeah, that's true. So you can have these kind of sticky surfaces, like flies have those, and bees and have those kind of feet that they can latch onto things. I thought, wow, I wonder if that gets to a point when, like on a drone, where it can just basically stick itself onto an airborne drone can stick itself onto the blade and do what you're talking about, which is maybe take an X-ray.
Yeah, it does seem reasonable. Yeah. That's not crazy technology. We have all sorts of crazy stuff that are,
right. The software to drive that will be, if anybody can do it, it's going to be Sky Specs can do it, because their software to fly those drones is remarkable. But you have to take it from basically a horizontal helicopter position and flip it over on its side and stick it to the blade. That's going to involve some sort of tilting going on, like a tilt rotor situation. But yeah, it's possible. It's totally possible. And if the situation warrants it, the one that really I think warrants it is the offshore turbines and the blades offshore, just because you're kind of hanging out on a boat and things are turbulent. You only want to do this one time. If you're out there scanning it with a drone and you do find something that does need that secondary look, you would like to be able to take that look while you're out there instead of going back to wherever. It sounds like some of these boat rides are not fun.
No.
Do it while you're there and get the data all at one time. And some software engineer is got a lot of work ahead of him to do that, and some aerodynamicist has got a lot of work to do in front of him. But that's the next step, right? Because we're seeing two separate levels of information. Like there's the quick scan, leading edge erosion, lightning damage kind of numbers, and then we're seeing the second one, which is there's been a wrinkle in a fiberglass ply or some sort of balsa problem inside of the blade that most likely is a manufacturing issue that wasn't caught, that they're seeing out in the field, or a shipping issue that happened in the field where they had some buckling occur. That is going to take a little more technology to look at.
Yeah, gotcha. So speaking of leading edge erosion, you did a deep dive on this research article, leading edge erosion of wind turbines, effect of solid airborne particles and rain on operational wind farms. So what do you got? This is looks like you said it's a pretty interesting read.
This paper came out, it was published earlier this year. It's produced by the School of Engineering, Institute for Materials and Processes, the University of Edinburgh, Scotland, UK. And so that's Hamish Law and Vasilios Kostos. Sorry about that, I'm sure. But they had done a lot of research into, and obviously Scotland is one of those places where a lot of offshore activity and onshore activity, wind turbine activity going on, and it's a really harsh environment. I don't know if you've ever been to Scotland, but it's beautiful. Okay,
Yeah.
first off, it's beautiful, right? It's beautiful, but it's not always the best weather. And being on, there's some really wicked storms there. There's also a lot of salt and things flying around in the air that they're finding are causing the leading edge damage to blades. And the numbers they gave were remarkable. Let me just read some of this because I think it brings to light what's going on. It says, the energy losses associated with leading edge erosion on an operational wind farm are examined in this paper, with the average annual energy production dropping by 1.8% due to medium levels of erosion, with the worst affected turbine experiencing losses of 4.9%. Okay. Annually. Holy cow. That's a lot of damage and a lot of degradation to the performance of a wind turbine because of leading edge erosion. And what they're going through this paper is discussing more specifically is that they looked at wind turbine leading edges over like a 14, 15-year period, and roughly 90% of them had moderate levels of leading edge erosion damage. And half of them had severe leading edge erosion damage. Well, if that's the case and it's driving down your energy production numbers, that's got to get fixed. Now, what the paper seems to be focused on is there really isn't a great standard for wind turbines of what the environment looks like or how to test for it. If you can't test for it, then how are you evaluating products that are being applied to it? I know Polytech is sort of the leader in leading edge erosion protection devices. They seem to have a lot of success with their product, but there's competing views about how well those will perform in actual conditions. And what this paper is trying to point out is some of the leading edge erosion stuff that came out 5, 6, 7 years ago doesn't look like it's performing as it was intended to or as advertised. So there's a big dispute now as to what do you do, right? Because you put on this material, and the OEMs are doing the same thing, or the OEMs are saying we got this leading edge erosion material, they're putting it out in the field, and it doesn't do what they're supposed to do. And as the operator, what are you going to do? There's nothing to do besides eat the power loss, or try to repair it, right? So engineering wise, we shouldn't be here today. This is 2020. We shouldn't be guessing at this, my opinion. We would never guess on it on the aircraft side. That's for darn sure. We've had in the United States and in Europe, they've had national bodies looking at all kinds of erosion issues since the 1950s. So there is data out there.
Yeah.
I'm just not sure we're grabbing hold of it like we probably should. It's a big issue.
Well, what do you think?
Power output's big.
Yeah. What do you think that equates? I'm sure that's probably a lot of complex numbers just to quickly run, but I mean,
Right.
if it's 1, 2, 3, 4%, what does that look like
Per year.
Yeah, what does that look like financially? I mean, is that a loss of $10,000?
Oh, if you're losing half your energy production by, I saw that number tossed around today as a bunch of discussions in the United States. There's some congressional hearings over the last week or two about energy direction in the United States. And one of the numbers that got tossed out was, well, wind turbines are about 50% as efficient after the 15 years in service versus a brand new wind turbine. What the implication was that your power generation is dropped by a factor of 50%, so that you just don't, your theoretical power production over that 20-year lifespan is just nowhere near what is predicted. The congressional combat then ensued. Just to sum it up, like there was clashes at high levels this week about that. Now, I don't know how you get around that. Right? You either have to mod the wind turbine blades, put something additional on them, or do a bunch of additional testing. You're probably going to do both. Why haven't we done that?
Yeah.
Am I missing something here? Why haven't we done that?
Yeah, I guess it's a good question. I mean, you think that, because it sounds like that the factories are still making them in largely the same way. Obviously, they're getting longer, and so the
Right.
internal structures are getting stiffer and lighter. They're using more carbon fiber, stuff like that, to accommodate the bigger blades, because they're huge. But it doesn't seem like they're doing more aftermarket stuff. not aftermarket, but like it seems like the only solutions now are to improve them using aftermarket companies like Polytech. That's like why isn't someone installing something like that off the factory floor? Like why is lightning protection still so poor off the factory, rolling out of the factory? It's like why?
There's a mystery. Yeah.
I don't know.
Well, Polytech, I think it's installing some of their systems on OEM blades, which is a good step because
do it on the ground, inside, where you're not dangling from, the heavens.
It's just controlled.
Yeah.
Right. So you're going to get a much more consistent installation with a lower level technician probably. You do have someone who knows how to rappel and also put on these things. But one of the I think you're right. You still see blades being produced today that don't incorporate really much in terms of leading edge protection. And if it creates that sort of power loss over time, what's going to happen is the insurance market's going to start to play into it, and DNVGL is going to step into it and say, okay, everybody, here's what you're going to go do, and you're going to demonstrate this. It's usually measured in mass loss, right? So you measure the weight of your test article before you put it through a rain erosion test, and you measure it after, and then there's some sort of measurement on mass loss equals aerodynamic inefficiency, which equals power loss. So it would be relatively simple to put some numbers on mass loss and say you can't have this much mass loss after this much exposure time. One of the issues that this paper talks about also is the modifications that are made to the blades slightly degrade the aerodynamics, which is the other issue, right? So one of the reasons that the blade manufacturers don't want to put any sort of leading edge protection on is because the most popular solution, which is the Polytech solution today, has a little bit of an aerodynamic penalty associated with it because anything will. So they don't want to do that more than likely. So they have high efficiency when they're first installed, and then 5 years later they don't. So over the lifetime of the blade, I think you're better off putting on a Polytech kind of solution just because it's going to get the longevity there.
Well, then shouldn't they be engineering that solution into the overall design? I mean, we're talking about putting this Polytech sheath. It's not really a sheath, it's not enclosing the whole thing, but they're sticking it to the outside of it. And, if they carved in a little bit, then that has like a little nook, a nook to go onto it. Now it has the original aerodynamics instead of being over top. So
and I think that's where Polytech is working with the OEMs to incorporate it aerodynamically into the blade surface. The same thing, we have done the same thing on aircraft for a long time. We used to do the same thing at aircraft. We used to put the fixes over top the leading edges to protect the leading edges, which makes it aerodynamically not as good. And then there's icing issues.
It's like a bandage. Yeah, you're putting a Band-Aid on it.
It looks like a bandage. It looks like a secondary thought, right? And then we figured out, like, all right, let's just let's do some testing, and let's get NASA involved. Let's figure out how to do this. And now everything's aerodynamically really, really, really smooth. If you look at a leading edge assembly on a new aircraft, it's incredibly smooth.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.